Hi, hello everyone. Welcome back to my YouTube channel Sporifii Learn. Today, let's see what are the questions that you need to focus, and I'll explain with answers for DBMS Module 3 questions. I hope you have done with Module 1 and Module 2. And as I said, Module 1 of DMS and Module 2, if you have followed the plan which I had given, and if you're watching my channel without subscribing, make sure to subscribe and then watch the video. Let's start the video. First, what is normalization? Explain 1NF, 2NF and 3NF with example. First, let's see what is normalization. I'll be trying to explain both in English as well as Kannada. Okay. First, normalization andre it is a technique of organizing data. When you have particular data, this is the data, means you will be organizing that in a particular way. That is called as normalization. It is a systematic approach of decomposing tables to eliminate data redundancy in order to avoid the data redundancy and undesirable character, right? Insert, update and deletion anomalies. To avoid this, we will be using this normalization. Okay. And there are three types, that is 1NF, 2NF and 3NF. First we will be discussing 1NF, that is NF means normal form. First what it is saying is 1NF, it's nothing but defined to disallow multiple values and disallow multi-valued attributes, and so when you have a multi-valued attributes, composite attributes, I hope you know what are the types of attributes that is in DBMS, and to disallow that, like these attributes and their combination, we will use this first normal form. See, you can see here, if you have department name, number and manager SSN and the location, see, you can see it is connected. The primary key is the D number, which you know, which is underlined as the primary key. Okay, we will assume that each have a number of locations. The 1NF, that will be, see here, D name you will give something, number, manager, SSN and location. We can see this is not in 1NF because D locations, this have, it is not as atomic attributes. The first it is having many values, right? So we have to make it as first. That means what you will be doing, see, you will be splitting that as 3. Okay, research had 3 locations, that you split it as research and you gave for each of the locations. That is 1NF. Okay. Next we will see about the 2NF. I hope you got this. I'll be explaining in Kannada also. See, first ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿರೋದು, ಡಿ ನೇಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಮತ್ತೆ ಲೊಕೇಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಎರಡು ನೋಡ್ಕೊಳ್ಳಿ ಸದ್ಯಕ್ಕೆ, ಇದೇನು ಬೇಡ. ಓಕೆನಾ. ಈಗ ರಿಸರ್ಚ್ಗೆ ನಿಮಗೆ ಬಳ್ಳಾರಿ, ಶುಗರ್ಲ್ಯಾಂಡ್ ಮತ್ತೆ ಹಾಸ್ಟಾನ್ ಅಂತ 3 ಲೊಕೇಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಬಟ್ 1NF ಫಾರ್ಮಲ್ಲಿ ಏನಿರಬೇಕು, ನಿಮಗೆ ಒಂದೇ ವ್ಯಾಲ್ಯೂ ಫಾರ್ 1 ಆಟ್ರಿಬ್ಯೂಟ್ ಇರಬೇಕು ಅಂತ ಹೇಳಿರೋದು. ಸೊ ನೀವೇನು ಮಾಡ್ತೀರಾ, ರಿಸರ್ಚಿಗೆ ಬಳ್ಳಾರಿ, ಆಮೇಲೆ ಶುಗರ್ಲ್ಯಾಂಡ್ ಮತ್ತೆ ಹಾಸ್ಟಾನ್ ಇದೆ ಅಲ್ವಾ, ಇದು 3 ಒಂದಕ್ಕೆ ಇದ್ದಿದ್ದು. ಆಯ್ತಾ, ಇದನ್ನ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ರಿಸರ್ಚ್ ಅಂತ ಹೇಳಿ 3 ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ 3ಕ್ಕೂ ಲೊಕೇಶನ್ಸ್ ಬರೀತೀರಾ. ದಟ್ ಈಸ್ ಹೌ ದಿಸ್ ಫಸ್ಟ್ NF ವರ್ಕ್ಸ್. ಓಕೆ, 1NF. Next is about the second NF. Again, you can see here SSN and 2 primary keys are there. This is a relation schema. If it is non-prime attribute A in R, it's fully functional dependent on the primary key of R. Okay, see, first you can see here SSN and P number, hours, ename, P name and P location is there. And here also you can see the table which is given, and they split it as see, SSN you split it, P number it's here, hours, and here you put it as ename, and P number, P name and P location. What you splitted it as FD1 and FD2, and you splitted it as basically functional dependencies. Okay. Next is about the third normal form. If you have functional dependency from X to Y, if it is a transitive dependency, if there exists a set of attributes and that exists a set of attributes that are neither a primary nor a subset of any key of R, that is both X to Z and Y to Z holds. That means if you have basically that it should be transitive means, I hope you know, if you have A to B, B to C, and that should be what linked to A to C also. If it is true, this also should be true. That we say it as what, transitive dependency. Okay, that is basically the concept of transitivity. If there is that for X to Y and Y to Z, X to Z also should hold. That is the basic idea they are trying to say. Okay, next if we see the example, they have given what, employment department. Okay, employee department means what they'll be having name, that is employee name, SSN, social security number, birth date, address, D number, D name, and manager SSN. You can split it. Okay. Next, if you have, for example, easy example I'll be giving this also, you can write it in examination, no worries. Student ID you can take, name, department ID, and department name you can take. Okay, department name I am taking. Student ID you can take it as 101, 102. Name you can take it as Asha and Ravi or anything else you can take. And department, this is 1, department this is 2. Here you can take as CSC and here you can take as AIML or anything. Okay. Now what is here student ID which is there, that is linked to name and department ID. Department ID which is there, it is linked to department name. Okay. Now if we have to convert it into 3NF, see, depends, what you will understand is department name is depending on department ID. Okay, not on student ID directly. Okay, because this is transitive, because so the table it's not in 3NF because this is depending. Okay, not directly on this, but it's depending on department ID. So when you have to convert it, you will make it as separate student table. Okay, in that ID, name and department ID you will be splitting. In next another one table, department table, you will be doing department ID and department name you will be splitting. Now this is what you say, you will be just writing the details which I have given again, and here also the same. Okay, that is called as 3NF. I hope you can see here the definition. It's if it is in third normal form and no prime non-prime attribute, only prime attribute should be there, that is called as 3NF. Next is, what are the informal guidelines for relational schema design? You have to focus is clear schematics of attributes. Okay. If example, employee and data department should be stored separately. Mixing of that both will be like causing semantic ambiguity. Like you will not get what is about the student, what is about the department and all. So in order to that, you will be having different tables for employee and as well as the student. And next what you have to do is reduce redundant information and update anomalies, which you saw in the previous. If you have redundancy, means repetition and inconsistency during updates may cause. And next you can see types also have given, that is insertion, deletion and modification. And next, reduce null values. Null values when you give, it will be taken as null, right? ESSN or office number, if you give null, it will be like causing some redundancy and inconsistency data set, right? So you should avoid the null values. And spurious tuples also you should be avoiding, that is like the relation should be designed so that join operations do not generate invalid tuples called as spurious tuples. When you have one data set, that is should be present in such a way that join operations can be done. Okay, that should have primary and foreign key. And improper decomposition of employee project may cause extra invalid tuples after join. Next, I have given a problem. First, what is the functional dependency? Is a constraint between two set of attributes in a relation, and you can see that. And next, you can see they have given B to A, D to A, AB to D. Okay. Now, what you have, you should split it as single attributes. First, A to B to A, D to A, AB to D. Right. Now, what you will be doing? B to A. Now again what you will be doing, here you can see B to D they have given, and next is AB to D, that is extraneous, and next with B to D they have given. Now you got the set becomes this B to A, D to A and B to D. Now what you will be doing, redundants, that is you will be checking. Okay, check for B to A, B to D, D to A. By transitivity it is redundant. So you will be having this as minimal cover B to D, D to A. So B to A is also there. So you will be proving for that. Okay, I hope you got this. Next is about the type of update anomalies. As I said, insertion, update and deletion and modification you can do. These are nothing but to poor database design and the redundancy control you have using, that is causes data inconsistency and all. As I said, insertion, deletion and modification, that is update. Okay. When you see, if you have this data set, see when you have insertion, when this insertion anomaly occurs when some data cannot be inserted into the database without inserting unnecessary values. See, when you have 3 finance and manager is Roy, but no employee works in that department yet. Okay, see, there is no such people. Okay, that is you are having. So in order to that will give you this, we cannot insert department information without employee details without saying the employee name and employee id. You cannot insert to department name, department number and the manager, right? That is causing the insertion anomaly. I hope you understood. This deletion occurs when you want to delete when the data is only not present. If employee this is deleted, now if you give again, that's already deleted. Okay, now again you are trying to delete. And next, when you are trying to update is when its data is repeated multiple times and you must update everywhere. Okay, that must be updated everywhere. But if you want to update one side also, it will be updated in 2 3. If you have in id 2 3 also, the same name and details, it will be updated there also. That is this. And next you can see insert, update, delete, alter and drop. That is insert, you will see insert into table name column, this and all, and values will be inserting. Insert into student table, you will be having sid name and student id name and age. That is values you will give 101 and name and some age you will be giving. Update is what? Update table name and the column name you will be giving and value which you want to this, and where the condition which you want to update you will be giving. See, first update, what is the table name? Student age is equals to 20 we had given, set it to 21 and student id is 101 and now this updates the student id is equals to 101. The updates of age will be done from 20 to 21. Next is about the delete, that is table name, where and condition. See, delete from student 101 which you have inserted as 101 id for student, that will be deleted. Next is about the alter command. Alter is nothing but when you want to do changes in the table. Okay, that is you will be giving alter table name, column name and data type, alter table student, add address, varchar of 30. Varchar means, I hope you know, variable and character, anything you can give, and this adds a new column only it will add, that is using alter. Next, drop means drop table student, that is table name if you give, that it will be permanently deleted from the database. This is all about the insert, update, delete, alter and drop command from this DBMS. Next we can see inference rules, that is having reflexive, augmentation, transitivity. Okay, now addition also it's there, union, decomposition and pseudo transitive. First we will be discussing inference rule are to derive new functional dependency from a given set of functional dependency. When you have some functional dependency given, in order to arrive new, you will be doing this. And next is about, they are called as Armstrong's axioms. See, first reflexive, I hope you know, if y belongs to x, x also should belongs to y. That is the having, and I have given proof also. You can see augmentation is if x is belonging to y, then xz or some variable you can take z, that also should be belonging. Next, transitivity, I hope you know, xy, yz means xz should be there. Okay. Next, addition, union also have given, if xy and yz, then x to yz, that is x, this variable is same, right? So x to y, x to z means x to yz, right? That you should be having as union, that you add it. And next is decomposition means x to yz means you will be splitting, that is the converse of this union which we did, x to y, x to z was there, that means you made it as x to yz. Now this is given, you will be doing this. Okay. Now next is pseudo transitive, that is x to y you given and wy to z you have given, that means wx to z. Okay, y you can cancel it as it is in the right hand left hand side. Okay. Next you can see again the problem, it is almost similar to the problem which we have done. They have given A to C, A C to D, E to AD, E to H. You and G as A to C and E to AH are the equivalent they are asking. Now what you have given conditions, you write it, and now we will check whether, verify whether they are equal or not. Okay. First check for F to G. Okay. From F can we derive G? You are thinking. First E to what they have given, AD. Now for E you split it as A, H also you can be given as E to H. Now applying union rule, that is AH you make it as AH. Now A already given, A to C is also there, right? A to C is already there, okay, in the question. So already C is derived, means that means G can also be derived. All dependency in G can be derived from F. From F, if you take as the left hand side, all the dependency can be derived, means F to G also can be derived. Okay. Now G to F you can take. Now take G. You proved it for AC given, E to AH given. Split it and make it as A to C, and they have given E to A, you make it transitive, means E to C and A C to D. That is A C to D is also available, or E to D is also there. Okay, that means you proved it for A C to D also, and G it's not equal. So they are not equivalent. Why? Means from G you are not able to prove it for all, because D it's not happening. Okay, no dependency gives in G gives D. Okay, that is why you are not having this rule as equivalent. So you will write it as F and G are not equivalent. That's all for this. I hope you understood this question. If you have not understood, I'll be explaining it again. See guys, first what they have given us, I'll be erasing it. First, the question they have given is consider the two sets. Okay, they have given the set as F and G. So what you are considering? F. Okay, first you check that F. Okay, you take it. What you have to prove is F is equivalent to G or G is equivalent to F. These both if you prove, then it is said as equivalent. Okay, or else it's not. Now you check for, you have to check it for F to G. Now you need to prove A to C, E to AH they have given, right? A to C and E to AH. Okay, E to AD also they have given, AH also. You can take it as A to C and E to AH. Okay, F to G if you take. Okay, now you can take it as A to C, which is already in F. And okay, wait, I'll be erasing. First you will be seeing what? A to C. This is already in F. Okay, you are checking to F equivalent to G. Okay, A it's there, A to C is there. Now E to AD. Okay, E to AD it's there. Okay. So you obtained, so it is also by decomposition what you can do, E to A, E to H. Okay, again this is for E to AH you can do, here it is, right? Now by union again you can do it as E to AH. Okay, E to A, E to H, you can do it as E to A, E to H is also there, E to AH also you can do. Now F is equivalent to G, it's proved. Okay, now you want to check for G is equivalent to F. Now you take all these four values and check whether it is present here or not. A to C is present, no need to worry. E to AH is there, right? Now you split it, A and H, okay. Now what you will do, E to A take and E to A to C, right? A to C is here, okay. Now, but E to C is also where? E to C is the transitive function which we got, okay, but A C to D is there, that is not present. So D is not obtained, and the final set we can say it as equivalent, okay. I hope you got this. Let's discuss that numerical again, okay. First you can see, let's consider F is equals to the set which they have given this, and now you can see A to C is there, AC to D, and E you can split it as AD and E to H. Here name can be removed, okay, none can be removed since the remaining don't derive the removed, okay. That is what you can see, AC to D, okay, AC to D, C can be removed since A is C, okay. Now if you remove C, A to D it will be there, A to C, A to D, E to A and E to D, E to H, all you derived, okay. Now again if you take that G set also and do the same, you will be having A to C, A to D, E to A and E to H, that is equivalent to the previous which we got. So the answer is equivalent, okay guys. Here a bit mistake have happened, sorry for it, and this is equivalent, okay. First what you will be getting is A to C, A to D, E to A and F to H, okay. This is the both set which will be getting, so the answer is correct, okay. I hope you got that, and thank you for watching the video. Until next video, bye bye. That's all. Thank you for watching the video. Make sure to like, share, comment and subscribe to my YouTube channel. And if you are watching my channel without subscribing, make sure to subscribe and then watch. And thank you for watching the video fully. And I hope you have understood all the questions that comes under module 3. I'll be uploading module 4 also as soon as possible. And if you want one short video, please do let me know in the comment box. And until next video, bye bye.